Okay guys, we're going to be taking a look at a lot of polynomial graphs, and so in our efforts to do so, we're going to need to plug in a lot of x values into our function to find what y value our function would be at that x value. And so evaluating these is pretty key, and being able to do it 100% of the time without making a mistake, that's even more key. And so because these are so long, these polynomial expressions, I count here on f of x, we have a 5-term polynomial expression, this fourth degree thing, a quartic here. And so plugging in 1, that's not going to be so bad, but plugging in things like negatives, okay, that's going to affect the kind of answers you're getting here depending upon your exponents. And getting numbers like 2 that are not like 1, a little bit bigger, you can see taking 2 to the 4th power even will be affected greatly just because of that 4th power on there. And so what I want to do is I want to kind of go over how I expect you guys can use a calculator in order to get some values here. And so start with this, number 11. Taking a look at this, I just want to find out what our function values would be at these indicated x values. So remember that f of x, this is really the same as y equals, but we're really saying it's the y value at this x value, okay? So we could say that every point on a graph, okay, is some x comma y, but in other words, we're saying it's some x and then our function value at that x value. Or we could even represent this as an ordered pair like this. Okay, we often see things like that when we write, maybe the vertex of a parabola. We said negative b over 2af and negative b over 2a. This is the same kind of notation. You plug in an x value, and this is the y value at that x value. And so what I want to indicate here, and I want you to make a table as well though, but is basically this. All we're really doing is plugging these x values into our function and trying to find what we get here, like f of 1, what it actually equals. And so f of 1, what I want you to do is this. I want to see this on your paper. I want to actually make sure that you're writing this down. Whoops, that's not a squared. But plugging in everywhere we see an x, we're going to plug in a 1 instead. So actually, before I even get that far, what I would expect to see when you plug something in is everywhere you do see an x, right? We're making a substitution here. You need to be using parentheses. If you're not using parentheses, then you're going to set yourself up for failure on some of these plug-ins here. And so when we look at this here, let's go ahead and plug in 1. We're going to plug in 1 everywhere we see an x. And so because we have to follow the order of operations, what's going to happen when you plug in these x values is that we're always going to be dealing with our exponents first here, or if there's anything to do in the parentheses, but there's not. So we get negative 2 times 1 to the 4th. Well, 1 to the 4th is just 1. Plus now we get 1 to the 3rd, which is 1. Plus now 5 times 1 to the 2nd. We have to do our 1 to the 2nd first, and I get 1. Plus 3 times 1 to the 1st. Well, that's 3 times 1 minus 7 here. Now we can go back and we need to do our multiplication. Okay, so multiplication here, here, and here, we get negative 2 times 1 is negative 2, plus 1, plus 5 times 1 is 5, plus 3 times 1 is 3, minus 7 here. And then last but not least, we have to go back and do our addition and subtraction from left to right. So here to here, I get negative 1, and that would be plus 5 plus 3 minus 7. And then we would get negative 1 plus 5, which is 4, plus 3, minus 7. And then furthermore, we would get 7 minus 7. And all of this work just to determine that we really just get 0 when we plug 1 into this function. So one thing I want to point out is that, when you get a number like 1, this is kind of a whole lot easier to do than when you have a number like negative 1 or 2. So what we want to get good at is also being able to evaluate this on a calculator. And so what I want you to do is go ahead and get your calculator if you have a calculator. If you don't have a calculator, then get the one that you have installed on your computer or your TI. But let's open it up, and what I want to type in is essentially the same statement that we wrote out here. And by the way, in terms of work, you could show your work and get it this way, but I always expect to see you have at least plugged it in here and then went and found it on a calculator. But you have to show me this first step. So we would say negative 2, and we're literally just going to write our parentheses here, and we'll put 1 inside the parentheses, and then our power key is this caret key to the 4th. Then we say plus, now in parentheses we had a 1, and that's also to the power of something here, but the power of 3, plus 5, and then in parentheses 1 to the power of 2, and then we have plus 3 times in parentheses 1, and then minus 7. So with this right here, we'll just go ahead and hit enter, and we'll verify that we actually get 0. Now the neat thing about this is, for letter B here, we still have to write out what we're doing here. We say we want to find f of negative 1. So what we're getting is negative 2 blank to the 4th plus blank to the third plus 5 blank to the second. Oh no. Plus 3 times a blank minus 7. I hope you don't mind my slant expression here. But basically, we're going to plug in a negative 1 everywhere we see this. Now, interestingly, what happens this time is when we do our exponents first here, we would get negative 1 to the 4th power. That would actually turn out to be a positive 1. But when we move on here, we say plus now, negative 1 to the 3rd. Well, negative 1 times itself 3 times, actually a negative 1. And then we say plus now 5 times a negative 1 squared. We have to square our 1 first, our negative 1. So we get 5 times a positive 1. But over here we have just plus 3 times negative 1, which becomes a minus 3 minus 7. So now doing our multiplication, negative 2 times 1 is a negative 2. We have plus a negative 1. Looks like plus 5 times 1 minus 3 minus 7. We'll go ahead and evaluate these. These combine out to be a negative 3 plus 5 minus 3 minus 7. We get negative 3 plus 5. Here is a 2 minus 3 minus 7. And we get 2 minus 3. Well, that's a negative 1 minus 7. In the end, we get a negative 8 here. So hopefully I haven't missed anything. Man, that's a real bummer if I did. But what I want to show you is this. We're going to check and find out if I did. And so here's the method we're going to use. Because I've already typed all this in once on the first time, I'm actually going to hit second and then my enter key, and what you're going to get is the last thing we typed in. Now my goal here is to go back and put a negative in front of my ones. And so because when let's say I hit a negative here, I want to show you something, it erases the one that was there and it puts in a negative instead. So what I want to do instead is I actually want to put my cursor on the one, or the thing that I want to move to the right, and I want to insert a negative. And so insert, right behind delete it says insert. We're going to hit second, delete, and you see my cursor changes to a flashing underline. If I hit negative now, everything that was on the one or to the right of it bumps to the right. And so I'm going to do the same thing with all my ones here. I'm going to put on top of the one there, I'm going to hit insert negative. I'm going to head over to this one right here. I'm going to hit second, insert negative. And then I have one more negative to insert right here. So we'll insert a negative, we'll hit enter. We definitely get negative 8. Now, let me write these in. 0, negative 8. Let's find our y value and our x value equals 2. So again, you know, I've got to see this part. See? I actually want to see negative 2 times blank to the 4th plus blank to the 3rd plus 5 blank to the 2nd plus 3 times x minus 7 here. I want to see you take out all the x's and put in blanks. And then I want to see you actually have placed all the 2's in here first. Once you get to this part, though, we can just go grab our calculator. And again, you know, I can just clear this out. I can hit second enter. And this time I actually want to go back and change all these negative 1's just to 2's. So what we're going to do is I'm going to hit delete to delete the negative, and then I'll hit 2 to right over on top of the 1 there. So we'll delete the negative, hit 2 to right on top of that 1, delete the negative, 2 on top of the 1, and then last but not least, delete the negative, 2 on top of the 1. So what I'm going to hit this time, enter, and get negative 5. So this would actually give us 3 coordinate pairs on our graph that we could actually go graph that we know are on the curve of the polynomial. Okay, so I want to try this again down here for number 14. Except for this time I've given us a little bit more exotic values, and so I want to talk about what we end up with here. And so for f of negative 11, let's go ahead and just start with this. F of negative 11, okay, would mean everywhere we see an x we're going to put in a negative 11. So the first thing we're going to do is we're going to take out all of our x's here, take them out. We're going to put in blank parentheses. And so because we have negative 11, we have negative 11 here, negative 11, negative 11, you can see that this is going to be quite large. So what I'm going to tell you is skip this portion right here. We're going to skip all the work in between on something that has larger values like this, and we're going to go ahead and proceed to just get this into a graphing utility. Now, if you had a calculator, basic one, you could even type this in. Using your parentheses appropriately, we should get what we need. So we have 3. In parentheses, we have a negative 11, end parenthesis, and we're raising this to the power of 3. And then furthermore, we have plus. Now 6, begin parenthesis, negative 11, end parenthesis, to the power of 2, plus 12, in parentheses, negative 11, end parenthesis, plus 10. What we end up with is actually negative 3389. So we get negative 3389. That's certainly what I want to list up here, but I also want to make a table of values here, and what I want to indicate basically is that if we were to go to negative 11 on this graph, then our function would be down at this y value, which is ridiculous. It's going to be decreasing very, very quickly when we get to larger x values because of these higher powers. So how would I do something like f of a half? Well, first things first, I want to see this on your paper. Let's go plug it in. Let's go substitute. So we have 3 blank cubed plus 6 blank squared plus 12 times our x here plus 10, just taking all the x's out. And what we're putting into our function this time is this x value, x equals a half. So we're going to plug in everywhere we see an x. We're going to put in a half. And we're going to go evaluate this. Again, you can see how undesirable this would be to have to do this, showing every bit of work, but you could do it. But let's put it into our calculator. Now I'm going to hit second enter and pull this back up. Now the interesting thing is, if you want to write a fraction, we have to use the divided by key because 1 over 2 means 1 divided by 2 technically. So yes, you can use a decimal, 0.5, but I would be an advocate for just typing in 1 divided by 2. And because negative 11 takes up 3 character spaces, I was actually able to just type over it with 1 divided by 2 and take up the same number of spaces. We didn't have to insert anything. So I'm going to go through here and I'm going to put a half in for all of my x values. 1 divided by 2, and hit enter, get 17.875. So when we go to an x value of a half, we are at a y value of 17.875. That's super awesome. And then for our last one here, we'll do a negative 1/3. So first things first, let me put this in here, 17.875. Fix my 5 here. We get 17.875, just plugging it in there. And then for our c here, we're going to find f of 1/3. So f of 1/3, and it's a negative 1/3. So we would get this, 3x cubed plus 6x squared plus 12x plus 10. And we're plugging in a negative 1/3 in each of these spaces. And so you could actually use a decimal here as well. But if you know anything about 1/3, it's actually 0.3333 repeating. And so you putting a decimal would only be able to get an approximation. Us putting the actual fraction, we'll hit second enter, pull this back up, is going to give us an exact value. So I'm going to insert in front of my 1 here, I'm going to insert a negative, and I'm going to go right over my 2, I'm going to make it a 3. And so again, I'm going to, on top of my 1 here, I'm going to insert a negative, make my 2 a 3, and we say, okay, again here, we'll insert a negative, and we'll make my 2 a 3. Enter. So we get positive 6.5 repeating. When you see something like this and then it rounds the last decimal, it's just trying to give you what fit on the screen, but this is really 6.5 repeating. So we're going to write 6.55, and I'll put this on top of it, or we could even write 6.5 and then a bar on top of it, just meaning it repeats 5s forever and ever. So really important that we can plug in x values, any x value, and find a y value here. But you can see that with these polynomials, the bigger the x value gets, you're going to get really, really big y values here. And sometimes you plug in a decimal, so you're going to want to be able to do this on a calculator.